December 7th, 1943. Rabaul Harbour, New Britain. Lieutenant Commander Takeshi Nakamura stands in the dim salvage workshop, staring at an object that should not exist in this condition. An American Mark 14 torpedo, hauled from the wreckage of USS Wahoo 3 weeks earlier, lies disassembled on wooden trestles under harsh electric lights. The weapon's internal mechanisms gleam with machined precision, despite months submerged in tropical seawater. Nakamura runs his fingers along the torpedo's depth control mechanism, feeling the smooth action of gears that moved with hydraulic fluid rather than compressed air. No corrosion mars the bronze fittings. The electrical connections show signs of careful waterproofing that survived catastrophic hull breach and ocean immersion. His engineering team has spent 17 days examining every component, measuring tolerances, photographing assemblies. What they discovered challenges 6 years of Japanese naval doctrine about American industrial capability. Sir, Chief Petty Officer Hiroshi Yamada calls from across the workshop. You need to see the exploder mechanism again. The magnetic influence pistol is far more sophisticated than our intelligence reports suggested. For 2 years, Japanese submarine commanders had dismissed American torpedoes as inferior weapons plagued by depth control failures and premature detonations. Radio intercepts of frustrated American submarine captains cursing their malfunctioning torpedoes had provided reassurance to Imperial Navy strategists. The Mark 14's reputation as a fundamentally flawed weapon had become an article of faith within Japanese naval circles. But the physical evidence lying disassembled in Rabaul's salvage facility told a different story entirely. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The path that brought this particular Mark 14 torpedo to Japanese hands began not in the workshop at Rabaul, but in the frigid waters off the Kuril Islands on October 11, 1943. USS Wahoo, under the command of legendary submarine captain Dudley Morton, had been conducting her 7th war patrol through the Sea of Japan. The aggressive American submarine had sunk 4 Japanese freighters and damaged 2 more before Japanese anti-submarine forces finally cornered her in La Perouse Strait. The coordinated attack by 3 Japanese sub-chasers and air support from Paramushir Island overwhelmed even Morton's tactical brilliance. Depth charges bracketed Wahoo's position with methodical precision until a catastrophic explosion sent the American submarine to the bottom in 400 feet of water. All 79 crew members perished in the attack, but the sinking occurred in relatively shallow water near established Japanese patrol routes, making salvage operations feasible despite the challenging conditions. Imperial Navy salvage teams reached Wahoo's wreckage in late October, working from surface vessels equipped with diving bells and recovery equipment. The submarine had broken into 3 major sections during her plunge to the seafloor. The forward torpedo room, though flooded and damaged, remained largely intact with 2 Mark 14 torpedoes still secured in their storage racks. Japanese divers worked for 6 days in near-freezing water to extract the weapons using steel cables and pneumatic lifting bags. The recovered torpedoes arrived at Rabaul Naval Base on November 15th aboard the repair ship Akashi. Commander Nakamura, chief of the Technical Research Division's Weapons Analysis Section, received orders to conduct comprehensive examination of the captured American weapons. His team consisted of 12 specialists, including torpedo mechanics, electrical engineers, metallurgists, and explosives experts. The directive from Combined Fleet Headquarters emphasized the operation's priority. Understanding American torpedo capabilities had become critical as United States submarine operations intensified throughout the Pacific. Nakamura's first impression upon examining the intact Mark 14 surprised him. The weapon measured 21 feet in length and weighed 3,200 pounds, specifications similar to Japanese Type 95 submarine torpedoes. but fundamental design differences became apparent immediately upon closer inspection. The Mark 14 utilized a steam turbine propulsion system powered by burning alcohol and compressed air, producing a visible wake that Japanese torpedoes avoided through oxygen-fueled engines. American designers had accepted this tactical compromise in exchange for manufacturing simplicity and mechanical reliability. The torpedo's external construction demonstrated manufacturing philosophy fundamentally different from Japanese practice. American fabricators had used standardized components and throughout the weapon's length. Every fitting, valve, and connector showed evidence of mass production techniques with generous tolerances that simplified field maintenance. Japanese torpedoes, by contrast, employed hand-fitted components that required specialized tools and extensive training to service properly. Chief Yamada directed the initial disassembly process with methodical care. His team photographed each step, documenting component positions and connection sequences. The torpedo's outer casing came away in sections, revealing internal mechanisms that challenged assumptions about American engineering sophistication. The depth control system operated through a hydrostatic valve connected to horizontal rudders via a pendulum mechanism. Japanese intelligence had reported this system as notoriously unreliable, causing torpedoes to run significantly deeper than set depths. But physical examination revealed something intelligence reports had missed. The depth control mechanism showed clear evidence of recent modification. Newer components had replaced original parts, with modification dates stamped directly onto replacement housings. September 1943 markings appeared on the hydrostatic valve assembly. The Americans had been systematically upgrading their torpedoes, correcting documented flaws through standardized retrofit programs. Japanese weapons development followed no such systematic improvement process. Lieutenant Kenji Suzuki, the team's electrical specialist, focused his attention on the Mark 14's exploder mechanism. Japanese Type 93 torpedoes used contact detonators exclusively, requiring direct impact with enemy hulls to trigger warhead detonation. The American weapon employed a dual-mode exploder, capable of both contact and magnetic influence detonation. The magnetic pistol could theoretically detonate the warhead when passing beneath a steel-hulled ship, breaking the vessel's keel without requiring direct contact. Suzuki carefully extracted the exploder assembly from the torpedo's warhead section. The mechanism consisted of a magnetic sensing coil connected to a firing circuit through a complex series of relays and safety switches. Japanese intelligence reports had characterized this system as dangerously unreliable, prone to premature detonation or complete failure. But Suzuki's examination revealed sophisticated engineering that addressed precisely the problems American submarine commanders had reported throughout 1942 and early 1943. The magnetic influence circuit includes multiple redundant safety interlocks, Suzuki reported to Nakamura during the daily analysis briefing. The firing sequence requires simultaneous confirmation from 3 separate magnetic sensors before initiating detonation. This prevents premature firing from stray magnetic fields or Earth's magnetic anomalies near polar regions. The Americans designed this system to fail safe rather than fail deadly. Nakamura studied the exploder diagrams Suzuki had prepared. The contrast with Japanese torpedo doctrine became increasingly apparent with each day of analysis. Imperial Navy weapons emphasized maximum destructive effect and tactical flexibility through oxygen propulsion and exceptional range. American torpedoes prioritized manufacturing consistency, field maintainability, and systematic correction of operational deficiencies. Neither approach was inherently superior, but the philosophical differences revealed fundamentally divergent industrial strategies. The metallurgical analysis, conducted by Lieutenant Masao Tanaka, provided additional insights into American manufacturing capabilities. Tanaka had trained at Tokyo Imperial University before joining the Navy's Technical Research Division. His specialty involved examining metal composition and fabrication techniques to assess enemy industrial capacity. The Mark 14's components offered a comprehensive survey of American steel production, precision machining, and quality control procedures. Every major component shows consistent material properties within extremely narrow tolerances, Tanaka explained to the assembled analysis team. The Americans are using standardized steel alloys across their entire torpedo production. Bronze fittings show identical composition, regardless of which component we examine. This indicates centralized quality control and standardized manufacturing specifications across multiple production facilities. Japanese torpedo production suffered from the opposite problem. Different arsenals used whatever materials were locally available, resulting in component variations that complicated maintenance and reliability. Torpedoes manufactured at Yokosuka Arsenal required different maintenance procedures than weapons produced at Kure Naval Arsenal. American standardization eliminated such complications through industrial discipline that Japanese manufacturing culture found difficult to replicate. The propulsion system analysis revealed the Mark XIV's most significant advantage and its most glaring weakness. The steam turbine engine, burning alcohol fuel and compressed air, produced reliable thrust across a wide range of operating conditions. The system tolerated seawater contamination, temperature variations, and extended storage periods without significant performance degradation. Japanese oxygen-fueled engines offered superior performance but required meticulous maintenance and could not tolerate any contamination in their fuel systems. However, the American propulsion system's visible wake remained an insurmountable tactical liability. The Mark XIV left a clear bubble trail across the ocean surface, alerting enemy vessels to incoming torpedo tracks and enabling evasive maneuvers. Japanese Type 93 long-lance torpedoes, powered by pure oxygen engines, left virtually no wake and could approach targets undetected until impact. This single tactical advantage had dominated Japanese torpedo doctrine since the weapon's introduction in 1933. Commander Nakamura compiled his preliminary findings after 3 weeks of intensive analysis. The Mark XIV torpedo represented neither the technological masterpiece Japanese propaganda had warned against, nor the fundamentally flawed weapon that American radio intercepts suggested. Instead, the weapon embodied a distinctly American approach to military technology that prioritized industrial scale, systematic improvement, and field reliability over tactical elegance or theoretical performance. The torpedoes documented problems, depth control errors, premature detonations, and dud warheads resulted from correctable design flaws rather than fundamental engineering incompetence. More significantly, the physical evidence showed Americans were actively correcting these flaws through standardized modification programs. Japanese intelligence had interpreted American torpedo problems as permanent weaknesses. Nakamura's analysis revealed them as temporary obstacles that American industrial capacity was systematically eliminating. But Nakamura's most disturbing conclusion emerged not from what the Mark XIV could do, but from what its existence implied about American submarine operations. If American submarines were achieving significant success despite operating with flawed torpedoes throughout 1942 and early 1943, what would happen when those flaws were corrected? Japanese merchant shipping losses were already approaching unsustainable levels. The Mark XIV's systematic improvement program suggested those losses would accelerate dramatically as American torpedo reliability improved. The second Mark XIV torpedo recovered from Wahoo's wreckage provided additional data points for Nakamura's analysis. This weapon showed even more recent modification dates, with December 1942 stamps on multiple components. The Americans had been refitting their torpedo inventory at an extraordinary pace, suggesting industrial capacity far beyond Japanese estimates. Imperial Navy arsenals required months to implement design modifications across existing weapon stocks. American facilities appeared capable of accomplishing similar tasks in weeks. Chief Yamada discovered another significant detail during the final disassembly phase. The Mark XIV's warhead contained 660 pounds of Torpex explosive, a considerably more powerful explosive compound than the standard TNT used in Japanese torpedoes. Torpex combined TNT with RDX and aluminum powder to produce approximately 50% greater blast effect than conventional explosives. Even accounting for the Mark 14's reduced range compared to Type 93 torpedoes, the American weapon's warhead delivered comparable destructive capacity on target. The implications of this discovery troubled Nakamura considerably. Japanese torpedo doctrine emphasized maximum range and speed to enable long-distance attacks from safe positions. But if American torpedoes could deliver equivalent destructive effect at shorter ranges while maintaining superior reliability and field maintainability, the tactical equation became less favorable for Japanese forces. Superior technology meant nothing if weapons failed to function properly in combat conditions. Lieutenant Suzuki completed his electrical systems analysis on December 5th, presenting findings that fundamentally challenged Japanese assumptions about American technical sophistication. The Mark 14's firing circuits employed vacuum tube technology, miniaturized, to fit within the torpedo's limited internal space. The circuits included multiple redundant pathways and built-in testing systems that allowed submarine crews to verify weapon readiness without expending expensive torpedoes in practice shots. The Americans have engineered their torpedoes for operation by average sailors rather than highly trained specialists, Suzuki concluded in his technical report. Every major system includes diagnostic capabilities and simplified maintenance procedures. This design philosophy accepts slightly reduced performance in exchange for dramatically improved operational availability. Japanese torpedoes require expert handling. American torpedoes require only competent handling. Nakamura recognized the strategic significance of Suzuki's observation immediately. Imperial Navy submarine forces consisted of elite crews trained extensively in torpedo handling and tactics, but Japanese submarine production could not match American construction rates, and trained crew casualties could not be replaced quickly. American submarines operated with less extensively trained crews, but could replace losses rapidly through industrial production and streamlined training programs. Weapons designed for average operators supported that strategic approach perfectly. The workshop at Rabaul maintained round-the-clock operations as Nakamura's deadline approached. Combined Fleet Headquarters expected his comprehensive report by December 15th to inform strategic planning for the coming year's operations. Every day of analysis revealed new details about American industrial capabilities and design philosophy. The Mark 14 torpedo, initially dismissed as an inferior weapon system, had become a window into American naval strategy that Japanese intelligence had failed to fully appreciate. The morning of December 8, 1943 brought unexpected visitors to Nakamura's workshop at Rabaul. Captain Mitsuru Yoshida arrived from Combined Fleet Headquarters in truck aboard a fast destroyer, accompanied by 2 technical intelligence specialists from the Navy Ministry in Tokyo. Yoshida's reputation preceded him. The stern-faced officer had served as torpedo officer aboard the battleship Kirishima before transferring to intelligence work following the ship's loss at Guadalcanal. His expertise in torpedo tactics made him the Navy's foremost authority on underwater weapons employment. Commander Nakamura, Yoshida announced without preamble after the formal introductions concluded, your preliminary report has generated considerable interest at the highest levels. Admiral Koga specifically requests detailed comparison between the American Mark 14 and our Type 93 Long Lance. The Admiral believes your findings may have significant implications for our submarine doctrine going forward. Nakamura had anticipated this request. For 3 days, his team had been preparing comprehensive performance comparisons using data extracted from the captured Mark 14 and official specifications for Japanese torpedo systems. The results painted a picture that would prove uncomfortable for officers who had built their careers around the Long Lance's supposed invincibility. The comparison presentation began in the workshop's conference room at 1400 hours. Nakamura had arranged both captured Mark 14 torpedoes on display racks beside a Type 93 Long Lance torpedo borrowed from Rabaul's armory. The visual comparison alone revealed fundamental design differences that would shape the afternoon's discussion. The Type 93 Long Lance represents the pinnacle of Japanese torpedo technology, Nakamura began, gesturing toward the sleek Japanese weapon. 24 feet in length, weighing 4,800 pounds, powered by a kerosene and oxygen engine producing 49 knots sustained speed across 22 miles. The weapon carries an 1,100-pound warhead capable of sinking any vessel afloat. No nation has developed a comparable torpedo system. Captain Yoshida nodded approvingly. These specifications had formed the foundation of Japanese torpedo doctrine for a decade. However, Nakamura continued carefully, the American Mark 14 offers certain operational advantages that our intelligence assessments have consistently underestimated. He moved to the disassembled American torpedo, indicating specific components as he spoke. The Mark 14 achieves 46 knots across 4.5 miles using a steam turbine propulsion system. While inferior in raw performance, the American weapon demonstrates superior reliability under adverse conditions and requires minimal specialized maintenance. Lieutenant Tanaka distributed technical drawings comparing the two weapons' internal layouts. The contrast between Japanese elegance and American practicality became immediately apparent. The Long Lance's oxygen propulsion system consisted of precision-engineered components requiring careful handling and meticulous cleaning. Any contamination in the oxygen fuel system could cause catastrophic explosions during torpedo loading operations. Japanese submarine crews trained extensively to prevent such accidents, but incidents occurred with disturbing frequency. The Mark 14's steam turbine system tolerated abuse that would destroy Japanese torpedoes. Saltwater contamination merely reduced performance rather than causing catastrophic failure. Temperature extremes that rendered Long Lance torpedoes inoperable barely affected American weapons. The Mark 14 could remain loaded in torpedo tubes for extended periods without degradation, while Japanese torpedoes required careful preservation and could not stay loaded for more than 72 hours without risking propulsion system damage. The Americans have engineered their torpedoes to function reliably despite operator error or adverse environmental conditions, Nakamura explained. This design philosophy accepts reduced maximum performance in exchange for consistent average performance across all operating conditions. For submarine warfare involving extended patrols and uncertain combat circumstances, this approach offers significant tactical advantages. Chief Yamada presented the maintenance comparison analysis next. His findings proved even more striking than the performance data. A Type 93 torpedo required approximately 40 hours of specialized maintenance for every 100 hours of storage aboard a submarine. Trained torpedo mechanics performed this maintenance using specialized tools and following precise procedures that allowed no deviation. Any shortcuts risked oxygen system contamination or control mechanism failure. The Mark 14 required roughly 12 hours of routine maintenance per 100 hours of storage, performed by ordinary sailors using standard Navy tools. The American weapon's design incorporated easily accessible inspection ports, standardized fittings, and color-coded systems that simplified maintenance procedures. Submarine crews could conduct most routine maintenance without specialized training, reserving expert technicians for complex repairs only. This maintenance differential translates directly into operational availability, Yamada concluded. American submarines can maintain higher torpedo readiness rates with fewer specialized personnel. Japanese submarines must carry additional torpedomen to maintain weapon readiness, reducing crew space available for other specialties. Captain Yoshida studied the maintenance comparison charts with visible discomfort. His experience aboard Kirishima had given him extensive exposure to torpedo handling procedures. The time and expertise required to maintain Long Lance torpedoes aboard surface vessels was considerable. Submarine conditions magnified those challenges substantially. Lieutenant Suzuki presented the exploder mechanism comparison next, focusing on the fundamental philosophical differences between Japanese and American approaches to torpedo detonation. Japanese torpedoes used exclusively contact detonators, requiring direct hull impact to trigger warhead explosion. This system provided absolute reliability, no premature detonations, no dud hits, no magnetic anomalies causing erratic behavior. When a long lance struck an enemy ship, it exploded with devastating certainty. The American dual-mode exploder attempted to provide tactical flexibility through magnetic influence detonation capability. Theoretically, a Mark 14 could detonate beneath an enemy vessel's keel, breaking the ship's back without requiring direct impact. This capability would allow single torpedoes to sink large vessels that might survive contact detonations against hull armor. But the magnetic pistol's complexity introduced failure modes that contact detonators avoided entirely. However, Suzuki added carefully, the captured Mark 14's exploder shows extensive recent modifications addressing documented reliability problems. The Americans identified specific failure modes through systematic testing and implemented engineering solutions across their entire torpedo inventory. The magnetic pistol, recovered from Wahoo, includes 3 separate safety interlocks absent from earlier Mark 14 designs. These modifications appear to have resolved the premature detonation problems that plagued American submarines throughout 1942. Yoshida leaned forward with sudden intensity. Lieutenant, are you suggesting that American torpedoes are now functioning reliably? Our intelligence reports indicate continued American torpedo problems as recently as August. Captain, I am suggesting that American torpedo problems are being systematically corrected through standardized modification programs, Suzuki replied. The physical evidence indicates a comprehensive improvement effort involving multiple arsenals and rapid fleet-wide implementation. Japanese intelligence may be receiving reports of torpedo failures from American submarines carrying older weapons, while submarines with modified torpedoes operate successfully without generating interceptable complaints. Implication hung heavy in the conference room's humid air. Japanese intelligence had based strategic assessments on the assumption that American torpedo deficiencies represented permanent technical incompetence. If American torpedoes were actually becoming more reliable while Japanese analysis assumed continued failure, strategic calculations throughout the Pacific theater might require fundamental revision. Nakamura proceeded to the warhead comparison analysis, presenting data that further challenged comfortable assumptions. The Type 93's 1,100-pound warhead using conventional TNT explosive delivered devastating destructive capacity against any target. Japanese torpedo tactics emphasized this overwhelming hitting power, accepting longer approach times and greater tactical risk to deliver near-certain kills on high-value targets. The Mark 14's 660-pound Torpex warhead carried approximately half the explosive mass of a long lance. But Torpex's superior blast characteristics partially compensated for the weight differential. Comparative analysis suggested a Mark 14 hit delivered roughly 65% of a long lance's destructive effect, sufficient to sink most merchant vessels and damage or sink many warships. Combined with superior reliability and operational availability, the American torpedo's reduced hitting power became less significant than raw statistics suggested. The critical factor is hits on target, Nakamura emphasized. A Type 93 torpedo delivers maximum destructive capacity, but only when it successfully reaches and detonates against the enemy vessel. A Mark 14 delivers adequate destructive capacity more consistently across varying combat conditions. For submarine warfare involving uncertain firing solutions and long-range attacks, consistent adequate performance may prove more valuable than inconsistent maximum performance. Lieutenant Tanaka presented the manufacturing analysis last, revealing industrial capacity differentials that disturbed every officer present. American torpedo production during 1943 approached 14,000 units across multiple facilities. Japanese production for the same period totaled approximately 3,800 torpedoes of all types. The disparity reflected not merely industrial capacity, but fundamental differences in manufacturing philosophy. American arsenals produced torpedoes using assembly line techniques with interchangeable standardized components. Workers with minimal training could assemble complex torpedo systems following detailed procedure manuals. Quality control occurred through statistical sampling rather than individual inspection. This approach prioritized production volume and consistency over absolute perfection in individual weapons. Japanese torpedo production emphasized craftsmanship and individual weapon optimization. Skilled technicians hand-fitted components to achieve maximum performance from each torpedo. Every weapon received individual testing and adjustment before fleet delivery. This approach produced superior individual weapons, but could not match American production volumes regardless of available raw materials or factory capacity. The Americans are producing torpedoes at nearly 4 times our rate, Tanaka concluded grimly. Even accounting for higher failure rates and reduced individual weapon performance, their volumetric advantage provides overwhelming tactical superiority. Japanese submarines face American targets protected by escorts that become more numerous each month. American submarines face Japanese merchant vessels with inadequate escort protection and declining numbers. The industrial mathematics increasingly favor American submarine operations. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Captain Yoshida requested a said in-depth, allowed in Zairi all, brief recess following Tanaka's presentation. The officers stepped outside into Rabaul's oppressive afternoon heat, seeking shade beneath palm trees that lined the workshop facility. Yoshida lit a cigarette with hands that trembled slightly, a gesture Nakamura recognized as suppressed emotion rather than fear. "Commander, your analysis is thorough and professionally presented," Yoshida said quietly. "It is also devastating to our strategic assumptions about American submarine capabilities. If your conclusions reach Admiral Koga unchanged, they will precipitate significant doctrinal debates at the highest command levels. Are you prepared for the consequences of challenging a decade of established torpedo doctrine?" Nakamura had anticipated this question as well. "Captain, I report the evidence my team has documented. The Mark 14 torpedo demonstrates capabilities our intelligence assessments failed to recognize. More significantly, it reveals American industrial advantages that no amount of tactical brilliance can overcome. These facts exist independently of whether my report acknowledges them. Suppressing inconvenient truths serves no strategic purpose." Yoshida nodded slowly, dropping his cigarette and grinding it beneath his boot heel. "Your integrity does you credit, Commander. But integrity without political awareness can prove professionally fatal. I will ensure your report reaches Admiral Koga with appropriate context. The Admiral values honest analysis, even when it contradicts comfortable assumptions. Others in the command structure may prove less receptive to your findings." The afternoon session focused on tactical implications of Nakamura's technical analysis. Chief Yamada presented operational scenarios comparing Japanese and American submarine tactics using actual combat data from recent engagements. The results confirmed patterns that Japanese submarine commanders had begun reporting with increasing frequency throughout 1943. American submarines operated with aggressive persistence that Japanese crews found difficult to counter. Despite documented torpedo problems, American captains pressed attacks repeatedly until achieving hits or exhausting their weapons. Japanese submarines, conscious of limited torpedo availability and replacement difficulties, operated more conservatively, breaking off attacks when initial salvos failed to connect. The tactical difference reflected industrial realities rather than courage disparities. American submarines can afford aggressive tactics because torpedo resupply occurs routinely at forward bases throughout the Pacific, Yamada explained. Japanese submarines must often return to home waters for torpedo replenishment, losing weeks of patrol time in transit. The Americans have created a logistical infrastructure supporting sustained submarine operations across vast distances. We have created individual weapons of superior quality, but cannot deploy them with comparable operational frequency. The captured Mark 14's electrical systems provided additional insights into American submarine capabilities. The torpedo's internal diagnostics allowed submarine crews to verify weapon readiness without actually firing test shots. Japanese submarines lacked comparable diagnostic systems, requiring periodic practice firings to maintain crew proficiency and verify torpedo functionality. Those practice shots consumed irreplaceable weapons that might prove critical during subsequent combat operations. Lieutenant Suzuki demonstrated the Mark 14's built-in test systems to the assembled officers. The American torpedo includes electrical test points throughout the firing circuit. Submarine crews can verify every critical system component using portable testing equipment, requiring no specialized training. The entire verification process takes approximately 15 minutes per torpedo. Japanese torpedoes require visual inspection of accessible components only, with no capability to test internal systems without actual firing. The quality control implications troubled Yoshida considerably. Lieutenant, you are suggesting that American submarine crews possess greater confidence in their weapons' reliability than Japanese crews have in our superior torpedoes. Captain, I am stating that American crews can verify their weapons' functionality before combat, while Japanese crews must trust that proper maintenance procedures have maintained torpedo readiness, Suzuki replied carefully. The psychological advantage of verified readiness may outweigh the tactical advantage of superior theoretical performance. Nakamura directed the discussion toward the strategic implications that would form his report's conclusion. The Mark 14 torpedo, viewed in isolation, represented neither a technological masterpiece nor a fatal threat to Japanese naval operations. But the weapon's existence revealed industrial and organizational capabilities that posed far greater strategic challenges than any individual weapon system. American industrial capacity supported simultaneous mass production of adequate weapons while maintaining active improvement programs correcting documented deficiencies. Japanese industry produced smaller quantities of superior weapons, but lacked the systematic improvement infrastructure to correct problems as they emerged. American submarine operations benefited from extensive logistical support, enabling sustained forward operations. Japanese submarine operations suffered from limited forward basing and inadequate resupply infrastructure. Most significantly, American military culture appeared willing to acknowledge weapon deficiencies publicly and implement corrections systematically. Japanese military culture treated weapon problems as matters of unit shame, requiring individual units to develop local solutions rather than systematic fixes. Radio intercepts of American submarine captains complaining of torpedo failures had been interpreted as evidence of inferior weapons. Nakamura's analysis revealed those complaints as evidence of a military culture that identified and corrected problems, rather than concealing failures to preserve institutional face. The Mark 14 torpedo teaches us more about American strategic culture than about American torpedo technology. Nakamura concluded his presentation. The weapon embodies industrial pragmatism, systematic problem-solving, and acceptance of adequate consistent performance over excellent inconsistent performance. These characteristics describe American military capabilities generally. Japanese forces must account for these factors in strategic planning, regardless of our tactical preferences. Captain Yoshida remained silent for nearly a minute after Nakamura finished speaking. The other officers waited respectfully, recognizing that Yoshida's response would determine how Combined Fleet Headquarters received Nakamura's analysis. Finally, Yoshida stood and bowed formally to Nakamura, a gesture of professional respect that carried significant meaning in Imperial Navy culture. Commander Nakamura, your analysis honors the Technical Research Division and serves the Emperor faithfully through honest assessment of enemy capabilities, Yoshida said formally. I will personally deliver your report to Admiral Koga with my strongest recommendation for immediate strategic review. Your team's work may prove more valuable to Japan's war effort than a dozen successful naval engagements. The December 15th deadline arrived with Nakamura's comprehensive report completed and ready for transmission to Combined Fleet Headquarters. The document totaled 87 pages, including detailed technical drawings, comparative performance tables, and strategic recommendations. Nakamura had spent 3 sleepless nights refining the language to communicate uncomfortable truths without appearing defeatist or undermining confidence in Japanese capabilities. The report's executive summary presented 5 key findings that would shape subsequent strategic debates. First, American torpedo technology, while inferior to Japanese systems in maximum performance, offered superior reliability and operational availability under actual combat conditions. Second, American industrial capacity supported both mass production and systematic improvement programs simultaneously, creating a dynamic capability that Japanese intelligence had failed to appreciate. Third, American submarine operations benefited from logistical infrastructure and forward basing that Japanese forces could not match given current resource constraints. Fourth, American military culture's willingness to acknowledge and correct weapon deficiencies represented a significant strategic advantage over Japanese practices that concealed problems to preserve institutional honor. Fifth, Japanese submarine doctrine required fundamental revision to account for American industrial advantages and changing tactical realities in the Pacific theater. Captain Yoshida departed Rabaul aboard the destroyer Shigure on December 16th, carrying Nakamura's report in a sealed dispatch case chained to his wrist. The document's classification level prohibited radio transmission, requiring physical delivery to Admiral Koga's headquarters in Truk. Yoshida promised to return within 10 days with the Admiral's response and any follow-up tasking for Nakamura's team. The wait proved agonizing for Nakamura. His analysis challenged fundamental assumptions that had guided Japanese torpedo development and submarine doctrine for over a decade. Officers whose careers had been built around the Long Lance's superiority would not welcome conclusions, suggesting that weapon quality alone could not overcome industrial and logistical disadvantages. Nakamura had documented the evidence faithfully, but professional consequences might prove severe if his analysis was perceived as defeatist rather than realistic. Captain Yoshida returned to Rabaul on December 28, 1943, arriving aboard the same destroyer that had carried him to Truk nearly 2 weeks earlier. Nakamura met him at the harbour facility, searching Yoshida's face for indication of how Combined Fleet Headquarters had received the torpedo analysis. The captain's expression revealed nothing during the formal greetings and transportation back to the technical research workshop. Only after reaching the privacy of Nakamura's office did Yoshida speak candidly. "Admiral Koga read your entire report personally, Commander. He spent 4 hours reviewing the technical sections with his staff torpedo officer and intelligence chief. Your analysis has been designated as critical strategic intelligence, with distribution restricted to flag officers and selected staff personnel only." Nakamura felt tension drain from his shoulders. Restricted distribution meant the report was being taken seriously rather than suppressed or dismissed. "What are the Admiral's instructions, Captain?" Yoshida opened his dispatch case and withdrew a sealed envelope bearing Admiral Koga's personal seal. "The Admiral directs you to expand your analysis to include all captured American submarine equipment currently available within the combined fleet's operational area. He specifically requests comparative assessment of American sonar systems, periscope optics, crew habitability provisions, and battery technology. Your team's charter has been expanded to become the Navy's primary center for analyzing American submarine capabilities. The assignment represented extraordinary professional recognition and equally extraordinary professional burden. Nakamura's small team would now be responsible for understanding the entire spectrum of American submarine technology at precisely the moment when American underwater forces were achieving devastating success against Japanese shipping. The magnitude of the task seemed overwhelming, but Yoshida was not finished delivering Admiral Koga's instructions. Additionally, the Admiral has directed that your findings regarding American industrial practices and systematic improvement programs be incorporated into revised doctrine for Japanese torpedo development and fleet weapons maintenance procedures. Captain Shimizu from the Technical Research Department in Yokosuka will arrive next month to coordinate implementation of your recommendations. This represents significant validation of your analysis, Commander. Admiral Koga does not authorize doctrinal revisions lightly. Nakamura absorbed this information with mixed emotions. Professional validation was gratifying, but the underlying strategic reality remained grim. If Imperial Navy headquarters was revising fundamental doctrine based on analysis of captured enemy equipment, Japanese forces were acknowledging disadvantages that tactical brilliance alone could not overcome. The war's trajectory was becoming increasingly clear to officers with access to unfiltered intelligence. The expanded charter brought immediate changes to Nakamura's operation. Within 2 weeks, his team grew from 12 specialists to 37, including experts transferred from research facilities throughout the shrinking Japanese defensive perimeter. Additional salvaged American submarine equipment began arriving at Rabaul from locations across the Southwest Pacific. Each shipment provided new insights into American submarine capabilities, while simultaneously revealing how comprehensively Japanese intelligence had underestimated enemy technological sophistication. In late January 1944, salvage teams delivered components from USS Sculpin, sunk by the destroyer Yamagumo off Truk in November 1943. The recovered equipment included sections of the submarine's sonar system, periscope assemblies, and remarkably, the boat's intact conning tower with plotting, table, and fire control equipment. Nakamura's team spent 6 weeks examining these materials, documenting American submarine warfare techniques that differed fundamentally from Japanese practices. The American sonar system, designated QC series equipment by U.S. Navy nomenclature, demonstrated technological sophistication that Japanese systems could not match. The equipment utilized frequency modulation techniques to achieve target discrimination in cluttered acoustic environments. Japanese sonar could detect contacts but struggled to distinguish submarines from whales, schools of fish, or thermal layers. American systems filtered ambient noise electronically, providing submarine commanders with clearer tactical pictures of their operational environment. Lieutenant Suzuki led the sonar analysis team, applying electrical engineering expertise developed during the Mark 14 examination. The Americans have invested heavily in signal processing technology, he reported during the POT, February status briefing. Their sonar equipment includes vacuum tube circuits, performing real-time frequency analysis of received acoustic signals. This allows operators to identify specific vessel types by their characteristic propeller signatures and engine sounds. Japanese sonar operators must rely on experience and intuition to classify contacts. American operators have technological assistance, providing consistent classification accuracy. The periscope assemblies from Sculpin revealed similar attention to operator effectiveness over pure optical performance. American periscopes used simpler optical designs than Japanese equivalents, sacrificing some magnification and light-gathering capability. But the American designs proved far more resistant to shock damage and required minimal maintenance under harsh submarine conditions. Japanese periscopes offered superior optical performance when properly maintained, but combat damage or neglected maintenance degraded their capabilities rapidly. Chief Yamada examined the practical implications during hands-on testing of the recovered periscope assembly. American periscopes are designed to function adequately, even when damaged or poorly maintained, he observed. The optical system uses fewer lens elements, reducing alignment sensitivity. The raising and lowering mechanism employs robust hydraulics rather than our precision-geared systems. Everything about the American design prioritizes continued function under adverse conditions over maximum performance under ideal conditions. The pattern Nakamura's team had identified in the Mark 14 torpedo appeared consistently across all American submarine equipment. American designers accepted reduced theoretical maximum performance in exchange for enhanced reliability, simplified maintenance, and tolerance for operator error. This design philosophy reflected industrial confidence that adequate, consistent performance multiplied across large numbers of platforms would defeat superior individual performance from smaller numbers of less reliable systems. The crew habitability provisions recovered from Sculpin shocked Japanese submariners who inspected the materials. American submarines provided individual bunks for each crew member, a luxury unknown aboard Japanese boats, where crews often hot-bunked with 2 or 3 sailors, sharing each sleeping space across different watch rotations. The American submarine included refrigeration equipment for food storage, enabling extended patrols with varied fresh provisions. Japanese submarines relied on preserved foods after the first week at sea. Most striking were the sanitary facilities. American submarines included multiple heads with fresh water washing facilities. Japanese submarines provided minimal sanitary provisions that became increasingly inadequate during extended patrols. The American approach reflected industrial capacity to build larger submarines with weight margins for crew comfort systems. Japanese submarines maximized weapons payload and fuel capacity, treating crew comfort as an unaffordable luxury. The Americans recognize that crew effectiveness degrades during extended patrols under harsh conditions. Lieutenant Commander Takeda observed after examining Sculpin's recovered habitability equipment. Takeda had recently transferred to Nakamura's team after completing his 3rd war patrol as executive officer aboard submarine I-176. His practical submarine experience provided valuable context for the technical analysis. They invest in crew comfort, not from humanitarian concerns, but from practical recognition that comfortable crews maintain higher operational effectiveness over extended periods. Our submarines achieve slightly longer theoretical range, but American submarines sustain effective combat operations longer because their crews remain fresh and alert. The torpedo fire control equipment from Sculpin revealed American advantages that purely technological analysis could not capture. The plotting table and mechanical calculator recovered from the submarine's conning tower showed extensive wear patterns, indicating thousands of practice tracking exercises. American submarine crews trained relentlessly with their fire control equipment, developing proficiency through repetitive practice that Japanese crews, constrained by fuel shortages and operational tempo, could not match. The mechanical calculator itself, designated the torpedo data computer by American nomenclature, automated calculations that Japanese submarine officers performed manually or with simple slide rules. The device integrated target bearing, range, speed, and course information with torpedo characteristics to generate firing solutions continuously updated as tactical situations evolved. Japanese fire control methods required officers to perform mental calculations or use time-consuming manual plotting techniques. The American fire control system treats the torpedo attack, a problem as an engineering challenge requiring mechanical solution, explained Lieutenant Morita, Nakamura's fire control specialist. Japanese doctrine treats torpedo attacks as an art form requiring skilled officers' intuitive judgment. The American approach produces consistent, adequate results from average officers. The Japanese approach produces exceptional results from exceptional officers, but inconsistent results from average officers. Given the attrition rates we are experiencing, consistent adequacy may prove strategically superior to inconsistent excellence. By March 1944, Nakamura's expanded analysis had documented systematic American advantages across every dimension of submarine warfare technology. The cumulative evidence painted a strategic picture that grew increasingly uncomfortable for Imperial Navy planners. American submarines operated with superior reliability, better crew effectiveness, more sophisticated sensors, and more consistent weapons. Performance. Japanese submarines maintained advantages in maximum speed, diving depth, and individual torpedo hitting power. But these tactical advantages could not overcome American industrial and technological integration. The most troubling finding emerged not from any single technological comparison, but from examining American submarine operations holistically. American forces had created an integrated submarine warfare system encompassing weapons, sensors, crew training, logistical support, and maintenance infrastructure. Each component was individually adequate rather than exceptional, but the integrated system produced operational effectiveness that exceeded the sum of its parts. Japanese submarine forces consisted of individually superior components, sophisticated torpedoes, deeper diving pressure hulls, faster surface speeds, but these components functioned as isolated capabilities rather than integrated systems. Torpedo excellence meant little when fire control systems could not generate accurate firing solutions consistently. Superior diving depth provided marginal advantage when sonar systems could not detect targets effectively. Maximum speed proved irrelevant when fuel shortages limited operational tempo. The Americans have built a submarine warfare machine optimized for sustained industrial warfare, Nakamura concluded in his March status report to Admiral Koga. We have built individual submarines optimized for decisive fleet engagements. The Pacific War has become a sustained industrial conflict rather than a series of decisive fleet actions. Our submarine force design philosophy no longer matches the war we are actually fighting. Captain Shimizu arrived from Yokosuka in April 1944 to coordinate implementation of Nakamura's recommendations into revised Imperial Navy doctrine. The 53-year-old officer brought decades of torpedo development experience and personal connections throughout the Navy's technical establishment. His assignment signaled serious intent to address the problems Nakamura's analysis had identified. But Shimizu's private conversations with Nakamura revealed the enormous obstacles facing any reform effort. "Commander, your analysis is technically sound and strategically valuable," Shimizu explained during their first working dinner. "But implementing your recommendations requires confronting institutional resistance from officers who have built their careers around existing doctrine. More critically, we lack the industrial capacity to manufacture American-style standardized components, even if we wanted to adopt their approaches. Japanese industry cannot simply transform itself into American industry through force of will." The conversation revealed the tragic dimension of Nakamura's work. His analysis had documented American advantages with scientific precision, but documentation alone could not overcome resource constraints and industrial limitations that were the war's fundamental realities. Japan lacked the steel production, machine tool capacity, electrical component manufacturing, and skilled labor pools that enabled American standardization and mass production. Understanding enemy advantages did not automatically provide means to counter them. Nevertheless, Shimizu and Nakamura worked through April and May to develop modified doctrine incorporating lessons from the American equipment analysis. The revised procedures emphasized torpedo reliability over maximum performance, simplified maintenance protocols allowing average sailors to conduct complex procedures, standardized training across all submarine crews to ensure consistent capability levels, improved forward logistics to reduce patrol downtime, and enhanced crew habitability to sustain effectiveness during extended operations. The new doctrine represented fundamental philosophical shift from emphasizing exceptional individual performance toward ensuring consistent, adequate performance across the entire submarine force. Implementation began in June 1944 with training programs at Kure Submarine School and revised maintenance procedures at forward bases throughout the remaining defensive perimeter. But by June 1944, American submarine operations had achieved such complete dominance that doctrine revisions could only marginally affect strategic outcomes. American submarines were sinking Japanese merchant vessels faster than replacement construction could proceed. The torpedo problems that had plagued early American submarines had been systematically corrected exactly as Nakamura's analysis had predicted. Modified Mark 14 torpedoes with corrected depth control and improved exploders were achieving hit rates approaching 70%, transforming American submarines into devastatingly effective commerce raiders. Japanese submarine forces, despite their superior individual torpedo technology, achieved nowhere near comparable operational results. The final irony emerged in August 1944, when Nakamura's team received salvaged equipment from USS Harder, sunk by Japanese destroyers near Tawi-Tawi in June. The recovered torpedoes included Mark 18 electric models, a completely new American weapons system that Nakamura had not previously examined. The Mark 18 used battery-powered electric motors for propulsion, producing no visible wake and leaving no bubble trail. The Americans had solved the tactical problem that Japanese oxygen torpedoes addressed, but through completely different technical means. The Americans identified wake visibility as a tactical liability and developed a wakeless torpedo using technology completely different from our oxygen propulsion system, Lieutenant Suzuki reported after examining the Mark 18. They achieved the same tactical advantage through alternative engineering approaches, demonstrating industrial flexibility that we cannot match. We developed one superior solution to the wakeless torpedo problem. They developed multiple adequate solutions and can shift production between them as tactical requirements evolve. Commander Nakamura completed his final comprehensive report on American submarine technology in September 1944. The document totaled over 300 pages and represented the most detailed analysis of enemy naval capabilities produced by any combatant nation during the Second World War. The report's conclusions proved grimly prophetic about the war's trajectory and about the limitations of tactical excellence when facing industrial and technological integration. Japanese submarine forces possess individually superior capabilities in specific technical dimensions, Nakamura wrote in his executive summary. American submarine forces possess systematically superior capabilities across the entire spectrum of underwater warfare. Individual superiority cannot overcome systematic superiority when conflicts extend across years and vast geographic distances. Japan's submarine doctrine was optimized for a war that ended after 6 months. The war that continues requires capabilities we cannot develop, given current industrial and resource constraints. Admiral Koga's headquarters distributed Nakamura's report throughout the Navy's senior leadership in October 1944. The document's impact on strategic planning remains difficult to assess, given Japan's increasingly desperate military situation by late 1944. But Nakamura's work influenced post-war Japanese naval development profoundly. The Japan Maritime Self-Defense Force that emerged after the war embraced systematic integration, standardized components, and reliability over maximum performance, all principles that Nakamura's wartime analysis had identified as critical to effective naval operations. The captured American Mark 14 torpedo from USS Wahoo remained at Rabaul until Allied forces recaptured the base in 1945. American salvage teams recovered the weapon and returned it to the United States, where it eventually found its way to the Navy's torpedo station in Newport, Rhode Island. Museum curators there learned its unusual history, a Japanese captured American torpedo that had taught Imperial Navy analysts more about American industrial capabilities than any intelligence operation could achieve. Lieutenant Commander Nakamura survived the war, though Rabaul's isolation in the conflict's final year meant his expanded research team accomplished little additional work. After mid-1944, he returned to Japan in 1946 and eventually joined the Technical Research and Development Institute of the Japan Defense Agency, where his expertise in comparative naval analysis proved valuable during Japan's post-war military reconstruction. In 1968, Nakamura published a memoir titled The Torpedo That Taught Us, describing his wartime analysis work. The book became required reading at the Japanese Maritime Self-Defense Forces Staff College, not as a technical manual, but as a case study in honest assessment of enemy capabilities, even when those capabilities prove superior to one's own. Nakamura argued that military professionals serve their nations most faithfully through accurate analysis, rather than comforting delusions, even when accuracy reveals uncomfortable truths. The Mark 14 torpedo's troubled development and eventual success became legendary in American naval circles. The weapon's early problems, depth control failures, dud detonators, and premature explosions, had caused devastating frustration for submarine commanders throughout 1942 and early 1943. But systematic investigation of failure modes, rigorous testing programs, and industrial commitment to implementing corrections had transformed a flawed weapon into an effective tool of naval warfare by mid-1943. The contrast between American and Japanese responses to torpedo problems illustrated fundamental differences in military culture and industrial organization. American submarine commanders reported weapon failures openly, even when such reports reflected poorly on Navy ordnance establishments. The Bureau of Ordnance, though initially defensive about criticism, eventually conducted the systematic testing necessary to identify root causes and implement corrections. The process was messy, contentious, and slow, but ultimately effective. Japanese submarine commanders who experienced torpedo failures tended to attribute problems to improper handling or operator error, rather than weapon defects. Individual units developed local workarounds for known issues, rather than reporting problems through official channels. The Imperial Navy lacked systematic testing infrastructure to investigate failure modes scientifically. Cultural emphasis on preserving institutional honor prevented the honest acknowledgement of weapon deficiencies that would be required to correct them systematically. By war's end, American submarines had sunk over 1,300 Japanese merchant vessels, totaling approximately 5 million tons of shipping. This commerce destruction campaign proved strategically decisive, severing Japan's maritime supply lines and crippling the island nation's ability to sustain its military forces. Japanese submarines, despite their superior individual technical capabilities, achieved far more modest operational results, focusing primarily on warship targets, rather than merchant shipping interdiction. The strategic consequences of these different operational approaches vindicated Nakamura's analysis about industrial warfare's mathematics. Japanese submarines, optimized for fleet engagements and equipped with maximum performance torpedoes, achieved tactical excellence in their designed mission, but contributed marginally to strategic outcomes. American submarines equipped with adequate performance torpedoes and optimized for sustained commerce warfare achieved strategic decisiveness despite individual tactical limitations. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The Mark 14 torpedo, initially dismissed by Japanese intelligence as an inferior weapon plagued by inherent design flaws, had revealed truths about modern industrial warfare that transcended technical specifications. Superior individual weapon performance meant little without industrial capacity to produce weapons in sufficient quantities, logistical infrastructure to deploy them effectively, maintenance systems to keep them operational under harsh conditions, and cultural willingness to acknowledge and correct problems systematically. Commander Nakamura's analysis, conducted in the humid workshops of Rabaul during the winter of 1943 and 44, had documented these realities with scientific precision. His work could not alter the war's outcome. Japan's industrial and resource disadvantages were too fundamental to overcome through tactical adjustments or doctrinal reforms. But his analysis provided a framework for understanding why tactical excellence and superior individual capabilities proved insufficient against an enemy that had mastered the systematic integration of adequate capabilities across, say, industrial scale. The captured Mark 14 torpedo, recovered from the wreckage of USS Wahoo in October 1943, had served as a window into American military culture and industrial practice. Through methodical examination of the weapon's components, design philosophy, and manufacturing characteristics, Japanese analysts had glimpsed the systematic advantages that would ultimately prove decisive in the Pacific War. Understanding those advantages could not overcome them, but honest assessment of enemy capabilities honored the professional obligations of military analysts more faithfully than comforting self-deceptions. In the end, the Mark 14 torpedo taught its Japanese analysts exactly what they needed to know, even though that knowledge came too late to affect strategic outcomes. The weapon revealed that modern industrial warfare rewards systematic adequacy over individual excellence, that consistent, reliable performance defeats inconsistent maximum performance, and that cultural willingness to acknowledge and correct problems provides strategic advantages, as important as any technical capability. These lessons, purchased through Japan's defeat, would shape post-war military thinking throughout the world and influence naval development for generations to come. The torpedo that American submarine commanders had cursed throughout 1942, the weapon whose failures had cost countless tactical opportunities and endangered submariners' lives, had ultimately proven adequate to its strategic purpose. And adequacy, consistently applied across industrial scale with systematic commitment to improvement, had proven sufficient to achieve decisive victory against an enemy whose individual weapons were superior, but whose industrial and organizational systems could not sustain effectiveness across years of sustained conflict. Commander Nakamura understood this truth as he compiled his final report in the autumn of 1944. The Mark 14 torpedo had been his teacher, and the lesson had been clear even if bitter. The war's outcome was already determined by factors far beyond individual weapon characteristics or tactical brilliance. Japan had built an exquisite military machine optimized for decisive short conflicts. America had built an adequate military machine optimized for sustained industrial warfare. The Pacific War had become the latter type of conflict, and mathematical inevitability rather than martial valor would determine the final result.